Okay, so I'm going to go through this pretty quickly. You should have your sheet in front of you and all of your formulas, so this shouldn't be too bad. First thing, molarity. Molarity equals moles of solute over liters of solution, and so I first need to convert my 45 grams of solute into moles. So I'm going to crisscross swoosh, okay, and I calculated that my molecular mass of this was 142. So 142 grams over 1 mole, sorry, underneath 1 mole. And so you're going to do 45 divided by 142, so you're 0.32 moles. So it's going to be 0.32 moles over, this needs to be in liters, so I'm going to divide by 1,000, and therefore it's going to be 0.2. So 0.32 divided by 0.2, and you get 1.6. Okay, so it's 1.6 molar. Make sure to have your units in. Okay, next one. Calculate the molality of a solution that has 50 grams of, so molality is moles over kilograms of solvent. So here you're in grams, so I need to get to moles again. So it's going to be 50 grams. I'm going to crisscross swoosh again. And I need to find the molecular mass of this. So if I'm not wrong, the atomic mass of calcium I think is 40. So 40 plus 28, because there are 2 nitrogens, plus 6 times 16. And if the calcium's wrong, guys, I'm sorry, correct me later. It's 164 grams, okay? And then you've got 1 mole. Now, when I do 50 divided by 164, I get 0.3. So it's going to be 0.3 divided by, I want to be in kilograms of solvent. I'm already in kilograms, so it's going to be divided by 500. And guys, if you want to be putting in units just to check yourself, I would recommend it. I'm just kind of short on time and want to run through these, so I'm not doing that right now. So I get 6.1 times 0.1 times 10. Sorry, times 10 to the negative 4th. And your units for this are going to be molal, because it's molality. Good. If the molarity of this is 5 molar in 2 liters of solution, how many grams are there in the solution? Okay, so my molarity is 5, so 5 molar equals, well, I have 2 liters of solution, so the 2 liters goes on bottom, and I don't know how many moles I have. Now, when you solve this, you're going to cross multiply and you get 10 moles. Here's the tricky part, though. I'm not asking about moles, I'm asking about grams. So I'm going to crisscross swoosh, and I'm going to convert this to grams. So what you need to do is calculate the molecular mass of NABR and then multiply and you'll get your answer. Okay. Number 4, what volume of 12 molar HCl is needed to make 400 mils of a dilute 5 molar solution? So guys, as soon as you see 2 different concentrations of the same thing, and I even put in the word dilute, you know you'll be using the formula M1V1 equals M2V2. Now, the hardest part of this, once you've recognized what type of problem it is where to put all your values. So, M1, I'm going to put my 12 molar. Now, it says what volume of this. So, I don't know what volume I need. So, that's why I'm going to put the V there. Then I have a 5 molar solution, and I have 400 mils of that. Cool. So, now I just have to solve for V. So, it's really easy, guys, if you read the question carefully. So, 400 times 5 divided by 12, and I get 166.7. Now, the units for this, notice I didn't convert to liters. My units are just going to be milliliters, and I'm done. Okay? Next one, what is the boiling point of a 3 molar solution of BaF2? Now, remember, your formula for this is delta T, okay, boiling, equals your Kb times your molality, and the molality, guys, is just a little m, times your number of particles. Okay? Remember, for number of particles, what that means is if it is an electrolyte, meaning if it is an ionic compound, meaning if it's a metal and a non-metal, then it's going to break up. If it's a non-electrolyte, if it's covalent, then it's not going to break up and it's just going to be 1 particle. So here, guys, my Kb is 0.512. I even give you your molality here instead of on the test you had to calculate it. So this is just going to be 3 times, now BaF2 is an ionic compound, therefore it's an electrolyte, and therefore it's going to break up into all of its pieces, which is 3. So all you have to do is say 0.512 times 3 times 3, which is 4.608. Here's where you have to think. I'm adding this to water, and this is going to raise the boiling point. So the normal boiling point of water is 100, and now I've raised it by 4.608. So my new boiling point is going to be 104.6. Let's try a freezing point one. So my KF, it's the change in temperature. It's the same formula, except this is going to be my KF. So my KF is 1.86. Now I'm going to crisscross, and now I need to multiply by my molality, which is 4. Then I need to determine whether NaCl is an electrolyte or a non-electrolyte. Well, since it is an ionic compound, it's an electrolyte, so it's going to break up into 2 pieces. So I'm going to do 1.86 times 4 times 2, and I get 14.88. Since this is a freezing point depression problem, what that means is that the amount that it's changed, 14.88, is how much below 0 it's going to be. So now this is negative 14.88. And guys, my units are always going to be degrees Celsius, and this is degrees Celsius. Sorry about that. All right, if the percent volume per volume for a solute is 8% and the volume of the solution is 40 milliliters, what is the volume of the solute? Remember, your formula for the percent by volume is the volume of the solute over the volume of the solution. So all you have to do here, what I would recommend, rather than the times 100%, just convert this into a decimal. So it's just going to be 0.08 because that's a percent in a decimal. Equals, here's the volume of my solute, which I'm trying to solve for, over the volume of my solution, so 40. So these problems should be really easy because all you have to do is 40 times 0.08, and your answer is 3.2, and you're done. Okay, so 3.2, my units are 3.2 milliliters, and now I'm done. All right, unit 13, awesome. Convert 600 calories to joules. Notice this is a little c, not a big C, so it's going to be 600 little calories. Crisscross swoosh. There are 4.184 joules in every 1 little calorie. Guys, I gave that conversion to you on the test, so please don't miss a problem like this. So 600 times 4.184, and you should get 2,510.4. 2,510.4. Your units are joules, and you're happy. How much heat will be absorbed by 25 grams of mercury when its temperature started at this, blah, blah, blah. Okay, as soon as you see the word heat, you should be using the formula, the only formula we've used for heat, Q equals mc delta T. The other formula, guys, is C equals Q over M delta T. Either one's fine. This is the one I give to you on your test because I like it more. Okay, so it's asking about heat, so you're solving for Q. You know your mass, which is 25. You know your C. It's given to you. It's 0.14 in this problem, so 0.14. And your change in temperature is TF minus TI. Your final temperature is 120. Your initial temperature is 65. So what you need to do is 120 minus 65, and you get 55. Okay, so 55 times 0.14 times 25. Now you get a positive number, and it's 192.5. Notice you've used grams already. You've used degrees Celsius in this part, so it only makes sense that my units would be joules. Now, your heat is positive, which makes sense because you're increasing temperature, which means you're absorbing energy, which means that it's going to be endothermic, which makes sense. Okay, the heat absorbed, again, I'm anticipating your joules to be positive, by a sample that's 24 grams is 3,000. Oh, look, there it is. It's positive. And its starting temperature is 70 degrees Celsius, and its ending temperature is this. What is its specific heat? So I'm still going to use Q equals MC delta T. Okay. Now, my Q I now know is 3,605 joules, and I'm going to use my units just to help me with my units for my C. My mass is 24 grams. I don't know my C, so I'm going to leave that out. And my change in temperature, my end is 96, so my final is 96. My initial is 70, so the change is 26 degrees Celsius. Okay, so it's going to be 3,605 divided by 24. Divide that by 26, and you get 5.77, so 5.8. Now for units, you're taking joules, and you're dividing it by grams and degrees Celsius, so those are your units, and you're done. Now, number 4 is a calorimetry problem. So the first thing you need to do, guys, is solve for your Q of water, and then you will solve for your C of your metal. Now, the way you know it's a calorimetry problem is because, because you're dropping a metal into water. Okay, so an unknown piece of metal is heated to this and drops in the calorimeter K. So the information I know about water, I'm just going to solve for water. I would write out all the information, guys. I just don't have space. So Q equals, I know my mass of water is 120. My C of water, I always know, is 4.18. Now I need to know the change in temperature of the water. So crisscross K. So initially the water was at 24.5 degrees Celsius and it ended at 34.5, which is a change of 34.5 minus 24.5 is 10. So now what I do with my calculator, 120 times 4.18 times 10, and I get 5,016. So that is the heat the water absorbs, which, since we're assuming no heat is lost, equals the heat that the metal loses, meaning it's going to be negative, so negative 5,016 joules. Now, I know the mass of my metal. The mass of my metal is 20. I know the change in temperature of my metal. It started at 79.5 and ended at 34.5. So 34.5, because the metal and the water end at the same temperature. 34.5 minus 79.5 is negative 45. So what I need to do is plug these in. So Q is negative 5,016 equals 20 times my C times negative 45. When I divide, guys, divide by 20, divide by negative 45, I get point. Does that make sense? No, hold on one second, sorry. 5016 divided by 20 divided by 45. I get 5.6, and it's going to be joules over gram degree Celsius. Notice it's positive because these two negatives cancel. A C can never, your specific heat can never be negative. Last two problems. Determine the delta H. Okay, so for this problem, guys, what I'm going to be doing is I need to create this formula right here. So I want to put Mn on this side, and I don't want anything in front of it, so it's here right now. So I'm going to flip it. I'm going to flip, and that's what I'll show there. So my delta H is going to become positive. And then I also want to divide this whole thing by 3. So I'm going to rewrite this. It's going to be Mn plus 2/3 Al. Oops. Maybe this won't work so well, guys. Al2O3. Okay. Yields MnO2 plus 4/3 Al. The other thing I need to do is divide this whole thing by 3. Make sure you're showing, the thing a lot of people forgot to do was show what happens to delta H. Now here, let's keep looking. My O2 is here. My O2 is here. I'm happy with that, but I need to divide this whole thing by 1/3. Or multiply it by 1/3 or divide it by 3. That's the same thing, right? So divide by 3 or multiply by 1/3, same thing. So now I get 4/3 Al on this side. And I'm just going to write it here to save time. And 4/3 here. And 2/3 here. So what you'll notice, guys, is the following happens, and I'll do this in purple. My 2/3 Al2O3 on this side and my 2/3 Al2O3 on this side cancel. My 4/3 Al on this side and on this side cancel, and what I end up with is O2. Okay, so it's Mn plus O2 yields, because there's nothing else on this side, yields MnO2, and that's all that's left over because I've gotten rid of everything else. Okay, so I've got my final reaction, which is what I wanted, but now what I need to do is add these up. So I've taken the 1,789, made it positive, divided it by 3, and then I need to add the negative 3,352 and divide that by, having divided that by 3, and what I get is negative 521 kilojoules. And that's what you get. So guys, not only showing what you do to the reaction, but also showing what you do to your delta H is vital. Okay? Alright, last quick thing. For this, guys, what a lot of people forgot to do was products minus reactants. So you need to do 6 times the heat of reaction of O2, which is 0, plus this, which is negative 1,274.5, okay, minus your reactants, which is 6, I'm going to put this in parentheses, 6 times negative 393.5, plus 6 times negative 285.8, and guys, I'll put the answer up online because I've run out of time.